Morning. So today's attendance question. Remember, tomorrow is our test. It's test 2. It will be over chapter 2, the derivative calculation skills. If you're attending online, please check to see if you have your clicker link. I only see 2, a live link. There's George. Okay, so Ian, George, and Laura. So there must be 2 students that didn't know the link. So Dylan and Jada, you don't have the link.
I have my link.
Sure. You can bookmark this link or you can write it down. It's in the chat link. It will be the same link for both of you. Yeah, I can see. I'm sharing my computer screen, so on your side you can still be able to see it. If you don't have the chat window open, you can see it from the screen. But if you want to copy and click on link, you have to go to chat. It's typed in that in chat. So if you don't have the chat, if you're using a device that doesn't show the chat, you can write it down and then copy that, write it into your address. Anything else? Let's see. Okay, so 1, 2, 3, 4, 5. 7. X's. Well, this is your name. All right, let's try to work out this question, and this is for today's attendance. And also for participation, and this is one of the questions where the function is given and we're trying to find a derivative value. So f prime 2 is the slope of the tangent line at the point 2. Point 2 would mean, by point 2 would mean the point where the x value equal to 2. All right, if it's this kind of calculation, the answer should be a number because we really are looking for a single value, not a entire function. But usually if you want to calculate it, you should first find the function and then plug in x equal to 2 to find the value. So that's kind of the idea. So the first thing we should do is to try to find the derivative function. On the outside, it's a root function. So the number one things we need to know is how to find the derivative of a root function. And let's try to look at an example. If you have a, let me call this g of x equal to square root of x. Okay, and then we're trying to find derivative of this. So the question is try to find root of 2x, but you have to know how to differentiate root of x before you're able to differentiate root of 2x. And this is the kind of question we might have done in our process in our homework question, like section 3, 2.3 is basic differentiation rules. Now, a power rule is one of them. When we try to differentiate the square root function, one of the method will be, if you don't already know the derivative. So many of you have done this before, you know the derivative root of x is 1 over 2 times root of x. But if you don't know it, then the process of determining the derivative is first you write it into a power form. You write x in x to the power 1/2. Root of x and x to the power 1/2 is essentially the same thing, but having it in power form, you can now apply power rule. So according to power rule, And then again, I hope you do remember power rule. If you have x to the power n, any n, any number n, the derivative of x to the power n is n times x to the power n minus 1. That's power rule. Now, according to power rule, derivative of this function, you move the power to the front. That's where the n is supposed to be. And then the power has to minus 1. The 1/2 minus 1 is negative 1/2. So that's your derivative. But normally when we find, well, after we find the derivative, we would try to write it back to the original form. If the function is given in root form instead of power form, right now it's power form. So the derivative is power form, but we want to write it into the root form. So if we write it into root form, this is 1/2. There's a negative power division. So it's 1 over, that's the negative power. And then there's x to the negative 1/2. The 1/2 is going to be root. Okay, so that's how it is. And then if you want to simplify it, you can multiply numerator with numerator, 1 times 1, that's 1. And denominator with denominator, so that's 1 over 2 root of x. So this is the entire process of trying to figure out the derivative of square root function. But if you already have it or you already understand, then this is pretty much a actual review. Now let's look at this question. We are trying to find derivative of this one. So we're not differentiating root of x, we're differentiating 2 root of x. So according to the formula that we have here, root of x derivative is 1 over 2 times root of x. So root of 2x, the outside of the root. So according to the chain rule, we would differentiate the outside first. So then we have f prime of x is equal to 1 over 2 root of the inside. Now the inside is 2x according to chain rule. When you're differentiating the outside, we don't change the inside, right? So root of x, we have 1 over 2 root of x. If it's root of 2x, we have 1 over 2 times root of 2x. So the inside is 2x, inside of the root. And therefore, whenever you have a root, you put root of 2x. But that's not finished. We still have to find the derivative of the inside part. Right now, we're differentiating the root part. The root is the reason we have this 1 over 2 times root. But then you still have to find derivative of the inside. Derivative of the inside is this. Okay, according to chain rule, we are trying to find the derivative of the inside function. You don't have to worry about the outside function. All you have is differentiating the inside function only. Derivative of the inside function is 2, right? Derivative of 2x is 2. So all we have to do is, as far as for the inside function, is multiply the 2. That's chain rule. According to chain rule, you would differentiate the outside function first without changing the inside function, multiply by the derivative of the inside function. So this is another exercise on how do we apply chain rule to find differentiation of this kind. All right, and you can see it's not identical to what we have here anymore because of the chain rule. We have a 1 over 2, which is a division by 2. We have the multiplication by 2, so these two are going to cancel. That's on the outside of the root. Inside the root, square root of 2, whenever we can't get it out, square root of 2 is irrational. So the 2 inside the root has to stay there. But the 2 outside the root will cancel the 2 that we multiplied. So as the result, after we canceled or multiply the 2 with a 1/2 is 1. So we have 1 over the 2x. But this is the derivative of root of 2x is 1 over root of 2x. And then we want to find square root of f prime of 2. So we have to plug in 2. So we're going to plug in f prime of 2. And that means 2 is going to replace the x value. So it's according to the formula. This is the formula. So we're going to calculate 1 over root of 2 times 2, which is 1 over root of 4. And root of 4 equal to 2. So it's 1/2. Okay, I hope it's it works out as you calculated. And really what we need for this question is all the calculation on the left. On the right part, we're just reviewing those formula. I mean, just in case you don't remember them. So all the calculation as solution to the question will be over here. And in class, we try to follow every step of the calculation. I hope that when you are answering question for the test tomorrow, make sure you write all your middle steps down, and so then they will like logically consistent with step 1, 2, 3, and then all your calculation will make sense. And also I give partial credit for the steps. So tomorrow, try not to leave anything blank. You see the example for the test. It's all short answer. So we're supposed to write down the answer. This test, I didn't have any multiple choice on it because it's not quite as conceptual as the first structure. So the first structure, we do have some short answers, some multiple choice. This test, most of them are in the same format as a homework question. So all the what homework is, you see the function, you find the derivative, you have to put out the entire derivative formula. Or you see a calculation, you want to find the tangent line. Now you have to work out the process and just answer the tangent line. So try to keep your, yes, tomorrow again is the second test. So try to keep your notes. If you bring your calculation of your homework, paper homework, I'll give extra credit for the test. So as in what happened for test 1, you are allowed to use a index card for the formulas. One formula card, a calculator, and if you wish to get extra credit for your homework, paper homework, and bring your homework, I'm not taking it with me, so I'm not officially grading your homework. I'm just trying to reward more students for writing things down. So, because to me, I feel like math do involve a lot of carry out writing, and at least me, I have to see things to make sense of it. When I try to think about something, if I don't write it down, it's like they're magically disappearing by themselves. In my head, I think it's step 1. And then when I look at step 2, if I didn't write it down, it's not there. Let me turn this off. So I see the value of writing things out as far as to help you think about things and also to help you remember clearly how the steps is. So giving extra credit for the paper homework is my way of trying to reward anyone who's trying to show the effort. Otherwise, well, most of you are doing the homework, and maybe you have already finished all your homework on WebWork. But those are the homework grade. And if you have all your homework still, then I'm trying to give extra credit. It doesn't have to be in any particular format. If you have write down all your calculation on the computer, you can show me how you were writing them out on the computer. If you have in your notes, you don't have to like tear them out of your notes. You can leave it in as long as you can show me, and then I'll give extra credit. So the format of the homework, it doesn't really matter as long as you did it on paper. All right, next question. Let me at least finish recording your attendance. So you should already know the answer. I hope the steps kind of make sense. But this is one more example on chain rule. Let's see if it's scanned well. I think it's reflection. Okay, that works. Anyone else? Let's see. Well, I thought I made it clear which one was right answer. You guys still are choosing the wrong one. It should be B. It's 1/2. If you had it wrong, you probably didn't notice when we were calculating it out. So those are the calculation. The answer is steps that we are displaying over. That's the solution. The final answer is 1/2. We calculate the derivative function, and then we plug in x equal to 2 to find the derivative value. And way over here on the right, they were just reviewing the formula. Okay, I'm still seeing one of the answers wrong. Or you, you just put it in and then didn't pay attention which choice did you put in? Or let me see.
I think it
It was you? Okay. Okay. All right, so let me turn this off. I think I got everyone's answer. All right. Any question for the homework or for the test that we should talk about at first? Any question? Any homework question that are still hanging there? Let me go online. In the class, I didn't hear any response. Do you have any question, any particular question you want to mention before we start talking about the practice questions? I'm gonna try to go over the practice question today. Since the test is tomorrow. Any questions? Any questions? All right, so let's together, we're gonna look at the test practice question. Georgia, if you go to content, in the content tab, we go to the left, it's weekly schedule. But basically, I'm trying to keep track what we did each day. And then the recording will also be in the weekly recording. Also, you can find the online link for Attainable. We already have plenty of attendance online. And then scroll down. Those are where I put the PowerPoint files. The online resource have some videos or files that I find helpful for calculus study. And there was some old video from before. All right, the test preparation is a folder that I was trying to store all the past test related material. So we have an example for test 1 and then solution for test 1. And then there's an example for test 2. So that was an example that I showed last week. So most of these questions and the tests are similar to our homework question. If you've done the homework, they should kind of look familiar. There are, I think I listed 14 questions, and on average is, well, let's see, we have how many sections? 2 sections. Chapter 2 is 7 sections, 2.7 is the last section. So pretty much 2 questions per section on average. And that's the implicit differentiation, which is in 2.6. This is logarithm differentiation. That's also 2.6. So you might expect there will be one calculation of y prime from equation, and then one calculation of the logarithm differentiation. I mean, if you are finding this difficult, it's time to try to go over your homework and really write it out to see if you're able to follow the steps, because it's to be expected, the kind of question that will be on it. This is the kind of question I always practice. We can definitely understand it, but if you have never practiced before, you may find it like you have no idea where to start. The method is called logarithm differentiation. So you take natural log of both sides of the equation and then try to differentiate it with implicit differentiation. Now, this is chain rule. You see, we have function inside a function inside a function. So there's 3 layers of the chain rule. That was also chain rule, and that's probably from section 5. So section 6, section 5. This is the division, so that's section 2.4. It's also 2.4. Multiplication is 2.4 for product rule, and those are formulas. 2.3, you have to remember the formula for how to define derivative logarithm and how to find derivative of the exponential function. And that's also from that section. This is also a derivative exponential function. And then we are moving back to section 1. I feel like maybe there's not a lot of question for 2.2 since we do have equation of tangent line. So that we're assuming that is to be like included. 2.2 is included in many of the 2.1 question, 2.0, 2.4 question. Otherwise, I maybe have omitted 2.7. I don't find any inverse trig in here. Right, so my plan is to put an inverse sine or inverse tangent question in there. I found that on this version, there's none. Okay, so try to finish all your homework so you will be prepared. The plan is to have 2 questions per section, so we have 14 questions. But when I look at this again, I realize there's more question for 2.4 than, right? I didn't put any question for 2.7, but put a few more question on 2.4. So we're probably gonna switch out the 2.4 question for one of those assignment on 2.7. So it's gonna be the plan. Have you guys looked at the solution yet? Any problem with the solution? Any question with the solution?
Can you go over question 13 and 14?
13 and 14. So we're gonna start with 13, and this is a similar question to, let me copy this question. It's similar to one of the question in 2.6 homework. So if you want to have additional practice other than this one, you should check your own homework. And of course, everyone are getting the different version. If you want to have more study, more example, you can study with another friends in the class, since you all might have a different copy of that question. So if we look at 2.6 homework with one of these. Yeah, like this. So pretty much the question that we had on the test for question 13 is similar to problem 6 on 2.6 homework. So if you don't know how to solve this question, that kind of is an indication that you might not have practiced this question on the homework, or you might not figure out how to solve it by yourself independently, because of course test is completely independent compared to homework, where we have a lot of help or tools. So you can see this is a number multiplied by cosine x to the power x. In the homework is sine x to the power x. So they have similar format, but definitely different version. So depending on what's your version of it, you might have sine, you might have cosine, you might have tangent. Essentially, we put a number time trig function to a power x. It's really the design of the question. All right, so let's try to figure out answer to this question. And I'm gonna try to start from the beginning, but if you are impatient, you can go online and look at the solution yourself. And that was in as preparation. This is question 13. Label that as question 13. So those are the answers. I put some of the formula over there that was useful, like this was logarithm. If you have product of a logarithm, if you have natural log of multiplication, and you put a summation of 2 small logarithm, this is a power rule. If you have logarithm of number to a power, and you could bring the power to the front of the natural log. So these are the rules that we might be able to apply here. This is a couple of trig equation. You have 1 over sine multiplied by sine, then sine divided, that's equal to sine multiplied by 1. So that's sine over cosine. Sine over cosine actually equal to tangent. So those are trig identity. So I was writing a couple of things there just so when we need it, you maybe remember them. Right. So that's the solution. If you want to read it directly, but if you go ahead and try to solve this question, then first we look at that was the calculation of derivative value. And if you want to calculate derivative value, the first thing is to try and define the derivative formula. We need to know this first. And remember that f prime of x is the same thing as y prime. Okay. And then if you have a formula for y prime and then plug in the necessary number, you will be able to calculate it. But remember, this is essentially the same thing, the y prime equal to f prime. Okay, so how do we find the y prime? I say y prime instead of f prime of x because obviously y prime is shorter. So as far as presentation and writing, we certainly want it to be more concise. So what we do is first thing is we rewrite it we write it as y equal to, oh, it's way too small. So we're gonna write y equal to, that was the original formula, y is equal to cosine of x raised to the power x. That's the original function. As you remember, f of x is the same thing as y, but I writing f of x made a longer presentation. Sometimes people find that's a little cumbersome to carry, especially if you have multiple steps. So single letter will always be more convenient. Same thing, the f prime of x actually equal to y prime, so y and y prime, they're differentiation of each other. Right, once we find the y, and then we now want to think about if we want to solve for the y prime, you have to have y prime in your presentation, your equation. So we're going to well, we cannot differentiate both sides of the equation, right? We don't have a formula. So what we're going to do is, since we have no formula for cosine x to the power x, we have no differentiation formula for it. So what we're going to do is take natural log of both sides of the equation. And that way it looks like this. So we have natural log of y, that was taking natural log of the left side of the equation. And then we have natural log of the right side of the equation as well. Since the computer, it's a little hard to write. So copy. Okay, so if you take natural log of both sides of the equation, we still don't have the derivative. And this process, the method that we're using right now is called implicit logarithm differentiation. So that's why we take natural log first, and then we're gonna find derivative. The derivative is the reason that we will have y prime. And once you have y prime in your representation, you can now find a way to solve it. So the reason that we do natural log is really to counteract that there's a variable to the power variable. In the exponential calculation, if the exponent is a variable, that's the exponential function. Is a base, has a x, is a power function. So now it's like both a power function and exponential function, and makes it complicated. So what we're doing is taking natural log, apply what we call logarithm property. So let's see how we like break them apart. What you have here, there's a multiplication and there's an exponent. So you might ask, is this a multiplication or is it exponent? It's exponent then multiplication. So on the outside, if you are trying to reverse it. So as far as the order of operation is exponent, then multiplication. So when you want to reverse it, you have to reverse the multiplication, then the exponent. So right now, the format is natural log of 5 times this number that we call cosine x to the power x. So according to the logarithm property, we're going to separate them. That with a plus. Okay, so we're going to separate them, and then it's going to like this. The reason that we have to spend time to break them down, because this is the reason why we take natural log, because it made it possible for us to break things into small parts. So we have natural log of 5 plus natural log of the cosine x to the power x. And then again, in the logarithm property, the power can be moved to the front. So this is applying the power rule. And the summation part is applying the product rule. So that's what we have now. Any question? Right. So as you can see, if I try to explain things, I do kind of explain things slowly. So if you're a little bit impatient, you can go ahead and look at the solution that's already posted on PeerTree. So now this is the logarithm part. So we finished the logarithm part, and then we have no more exponent of the exponent, variable to the exponent. So now we can think about differentiation. We're going to differentiate the left side of the equation. If you're differentiating natural log, you will have 1 over y. The inside of the natural log is 1 over y. This is applying the fact that when you have natural log of x, then the derivative is 1 over x Okay, but we have natural log of y, so the derivative is 1 over y. But then y is not x. X is a variable, it's an independent variable, but y is a function. So y is actually f of x. So this is natural log of f of x. So the derivative will be 1 over f of x multiplied by the derivative of f of x. So you do have to multiply actual y prime because they chain rule. So we multiply y prime. So this is caused by the fact that y is a function. Now, the right side of the equation, we have to differentiate one by one. If you differentiate natural log of 5, there's no x or y in natural log of 5. Natural log of 5 is a number. When you're trying to find derivative of a number, it equal to 0. So that is 0 plus. Okay, now we have to find derivative of this. That is a multiplication. So according to our rule in 2.4, if you have multiplication, I see that's a multiplication because you have an x here and you have the x there, and they're constructed with multiplication on the outside. So x times one more term with x in there. So that's why we say it's a product. If you don't have an x in here, if you have like 5 or 4, then you don't have to worry about the number. So x and then a number is different. It's definitely multiplication. So according to product rule, we have to differentiate 1, which in case will be x will be differentiated. And we're going to keep the natural log of cosine x plus, according to product rule, plus this time we're going to keep the x. We're going to find the derivative of natural log of cosine x. That's product rule. According to product rule, the differentiation of the multiplication would equal to differentiate 1 at a time while maintaining the multiplication. So that's what we have here. And now you can see every time I do product rule, I did this prime notation to do it slowly. But if you are fast, you should know that derivative of x equal to 1. Derivative of natural log cosine x is 1 over cosine time negative sign, right? There's a chain rule applied. So it's possible to do it fast, but I'm trying to keep the product rule application as careful as possible because I have the tendency of making small errors whenever I try to speed things up. So on the left side of the equation is a fraction multiplied by another term, so you can write it as y prime over y, so the division is shorter. And the right side of the equation, the 0 there, 0 is a summation of 0. You don't have to write it. And then derivative of x equal to 1. So that's really natural log of cosine x. Plus, then this is x, and we have to differentiate the natural log of cosine x. Derivative of natural log give us 1 over the inside, and the inside is cosine x. So we have 1 over cosine x. Now we have to multiply by the derivative cosine. Derivative cosine is negative sign. This is chain rule. The inside function is a cosine function. So you have to keep cosine. When you're differentiating the outside function, and you multiply the derivative of the inside function. That will be the negative sign.
So the natural log is the outside, and then the cosine is the inside.
Right, because we have, this is really natural log of cosine. So the cosine is on the inside of the log. The composition function is like stuffing the cosine inside the natural log. Natural log itself, ln itself has no meaning, but ln with a parenthesis followed by it. That parenthesis was supposed to be receiving the input. So if we don't have any input, then natural log has no actual meaning. We always have to. So this is really one single operation, one single number. We okay? All right. So this is pretty much all done. The rest of them is simplification. We would say we're solving for the y prime. So y prime is equal to, right? We multiply the denominator y to the right side of the equation. The original part on the right side of the equation is this. That's natural log cosine of x it's supposed to be a princess there. Sometimes I do get lazy and forget to write it. Plus, there's a negative term. So plus negative is actually minus. So minus x cosine is in the numerator, and then the sine is in the numerator, cosine is in the denominator. So that's really sine of x over cosine x. But then sine over cosine is actually tangent x. So the final answer will be y prime is equal to, you know, the y, this is a y. This is y. So y equal to 5 cosine x to the power x. That's the y multiplied by natural log of cosine x. Cosine x. And then minus x times tangent x. Sine over cosine is tangent x. So that will be the final answer for the whole derivative. So when we write the y prime or f prime of x, we should have only the x in there, x is the inputs. Are we okay? Any question? Any questions so far? All right, so that's our derivative formula. What we wanted to do is to find f prime of 1. So the calculation for f prime of 1 would be, okay, so f prime of 1 is equal to, we're going to plug in 1 for x, so it's going to be 5 cosine of 1 that you can use a calculator to calculate it. And then to the power 1, if the power equal to 1, we don't have to write it. And then there's a natural log and parentheses cosine 1, this natural log of cosine x, and then minus 1 times tangent 1. Since it's 1, slightly easier than other number. You can also calculate f prime of 3. Imagine if it's 3, it's going to be 5 cosine 3 to the power 3 multiplied by natural log cosine 3 minus 3 times tangent 3. So if it's 3, there's a little bit longer writing, because if it's power 3, you have to write it, but power 1, you don't have to write it. If it's multiplying by 1, you don't have to write it, but multiplying by 3, you do have to write it. So depend on the input. I see on my version of the Weber question, there's a 3 instead of 1. So that means the calculation is different. Any question? So that will be the solution for this. And so then this is the layout on the solution set, and then if you finish the calculation, 5 cosine 1 times natural log cosine 1 minus tangent 1, you're gonna get negative 5.887. So that's the final answer. The rest of the process are similar. Any question?
That in the not the f of 1s, but the y prime equals y. So that y, you're just subbing the first one, right?
Right, I'm substituting the 5 cosine x to the power x as a y.
Okay.
That's normally the last step in the logarithm differentiation. Because you started out letting this whole formula equal to y. And then that means you have two different versions for the y. You can write y as a variable, or you can write y as that formula, so that they are equaling each other out. So you can always switch it to a different version. Any other question? So then the last thing is sometimes people forget. So y times that logarithm of cosine minus x tangent is already a formula for y prime. Why do we have to switch the variable to cosine? And that's only because the mathematics, the way the question is given to you, is how you answer the question. If the question is given, you got a formula of f of x, which is a formula of x, and your answer will be f prime, also given is x as a variable. But if you have an equation like x, y minus xy minus y cubed equal to 10. Then when you try to find the derivative, your y prime can have both. Because in the question itself, x and y are being combined and both in the equation. So your answer can have a solution that has both the x and y. And that goes with a lot of other things. Sometimes we have a numerical question, and in the question that has decimal number, and then when you try to answer the question, the rounding is not given. You want to ask that do I round to 3 decimal or 2 decimal? The rule of thumb will be look at the question. If the question is all in 2 decimal, and your answer should also be 2 decimal. If the question have all the number in 6 decimal to be really accurate, so as a when you're writing down your answer, you should also round it to 6 decimal. So the question's rounding is an indication of how much number you should be. So whatever is being given is now what's being offered as a solution. And what's given is returned. Right. That's question 13. And let's talk about question 14. 14 is implicit differentiation. I think we has more exercise on implicit differentiation in section 6, but then the level of difficulty for 2.6, it depends on the level of difficulty or the complexity of the equation itself. That was one of these questions that's similar to question 102. So that's question 14. And then again, solution has been given in the Georgia review. We're trying to work out the process just to say how it is if we start from the beginning. That's our question. So it says you will be given the equation. The question is to find y prime at the point 2, 2. So the point 2, 2 is indicative of the x value and the y value. So this is saying x equal to 2 and also y equal to 2. That's what we mean by point 2, 2. So having those ready, we can think about where do we get y prime. As you can see, we were given the equation. Of course, the equation itself does not naturally have y prime. So how do we get the derivative? Sometimes with this situation, people will try to think of a way to solve the y. If you want to find the y prime, you might want to find the y. If you have a formula for y, find the derivative of that formula is your y prime. This one had a little difficulty. The equation has 2. There's a y in here, and there's a y in there. So if they are in a summation or multiplication format, you can combine them or factor them out. But now we can't. One is in the exponent, one is in a linear form. So multiplying two of the different type of question or combining different type of question sometimes is hard. So that e to the y is a transcendental function, but sorry, y is a algebraic function. So they're not easily combinable. So what we do is we are training this equation simultaneously and try to find a way to give us clue of the y. And this is really the fundamental idea of implicit differentiation. We try to differentiate both sides of the equation, so follow those steps. Step 1, we're going to differentiate both sides of the equation. Those sides. We're trying to find the root of both sides of the equation. It really depends. Sometime in 2.6, we have an equation that's kind of complicated. You might just think about try to figure out ways to do we change the equation a little bit before we differentiate it. This one, I don't see any like a situation that we have to do anything extra. So we'll just go ahead differentiate it. So for example, in 2.6, sometimes you have division, right? So if you have division, sometimes you have a power to a power 2. In that case, expanding it would be better before you differentiate it. But this one, let's go ahead and differentiate it. And we're going to do it by term by term. So there's 2 terms on the left. I'm going to differentiate the first term, that's multiplication. X is 1 variable, and there's a y. Right, so then that's obviously 2 of the different things that are multiplying. We have to do product rule. When we have multiplication, we're going to do product rule. according to product rule, we're gonna take the first one, want to find the derivative, keep the second one, plus this time we keep the x and differentiate e to the y, differentiate the y term. So that's product rule. Like right now, there's no calculation. We're just writing on the product rule to show that format of the product rule. F prime y, f prime g plus fg prime product rule. Plus, there's one more term. There's a minus 3y, so second term. The derivative of 3y is 3, but then y being a function, you have to multiply the y prime. So it's really negative 3y prime. That's what we have if we differentiate this term. Those are the kind of things that we will have to be able to get that experience or figure out if whenever you see negative 3y, the derivative, you have negative 3y prime. So sometimes we have to think the differentiation. Sometimes you see you immediately write down negative 3y prime because you have a couple of times tried the same thing. Any question? Right, so this is the left side equation. So left side equation seem to have more variable, and on the right side of the equation, you see there's 3x derivative of 3x equals 3. And then there's minus 12. 12 is a number. Derivative of 12 is 0. The 2e squared, it looks like an exponential function, and it is an exponential calculation, but we don't have the x or y, right? That one we have no x, we have no y in 2e squared. If you ask what is e is a number, is roughly 0.728. So an irrational number, the decimal is really long. That's why people invented a letter to represent it. There's a special number, but a number nonetheless. Therefore, it has no change. Therefore, it's zero derivative. So you can see, even though we have 3 terms on the right side, but then the derivative is 3. So focus on the variable. If you have x, if you have y, then you have variable. And therefore, what do we mean by variable is that thing will change. When the letter change value, the term change value, and then we have it's a variable because it's changeable. But you can see numbers such as negative 12 plus 2e squared, they don't change. Therefore, they're not variables. They're not variable. They won't change. They have 0 derivative. So right side of the equation seems to be more less variable, therefore less complicated term as the derivative. Okay, so let's try to finish the rest. These are the one that's already done. There's not much of work to do. And the one that we have those prime notation, this one and that one, those are the one that need more work done. So we have to focus on trying to get those prime removed and calculated. So, and then we differentiate the x. All right, the root of x equal to 1. That's 1 times e to the y. If we want to be more concise, 1 time anything equal to itself, we don't write it. That's e to the y plus x times e to the y differentiated. Remember, if you differentiate the x term, all you have to just go ahead and find the derivative. This is differentiating the x term. Over here, we're trying to find the derivative of e to the y. That is the y term. But remember in 2.6, whenever you have to differentiate the y term, you have to have y prime. Okay, so that's why the first one, we don't have y prime because we're not differentiating the y. We're differentiating the x, derivative of x equal to 1. And therefore, there's no y prime in there because we're not doing anything to the y term. But right now, this one we're differentiating e to the y. Derivative of e to the y is e to the y. But then we have to follow that with y prime. So it's e to the y. There is no change. That's the outside function. And then multiplied by y prime. That's inside function differentiation. This is a chain rule. Remember, chain rule will always cause us to have a multiplication. The multiplication of differentiating outside function multiplied by differentiating the inside function. The rest is, there's no change, so we have negative 3y prime, which equals 3. Remember, we're solving for y prime or evaluating y prime, so our target is to have y prime solved. So step 2 of the entire process will be, since you're solving for y prime, you have to have the y prime all grouped together. That means you have y prime here, y prime there, and then you won't be able to solve them. So often the way to solve a variable, the first thing will be having them all collected and combined, that you can solve it. So I'm going to try to combine the y prime terms. What do we have? These are the y prime terms. Okay, so there's 2 y prime term on the left side of the equation. And the one that do not have y prime, we wish to move it to the other side of the equation. So that's why we subtract e to the y prime. If you subtract e to the y prime here and then subtract e to the y prime there, the y prime will go away. And then you're going to have a minus y prime on the right side of the equation. So this will happen after you subtract them. Any question? All right, so we are moving all the term that has y prime to the left, all the term that has no y prime to the right. And you can think about the whole equation. There's only 4 terms. 1, 2, 3, 3 term on the left and 1 term on the right, 4 term. Among the 4 terms, 2 of them has no y prime, 2 of them has y prime. Now we rearrange the equation so then all the y prime is together. We're trying to combine the y prime since this one has y prime, that also has y prime. So y prime is a common factor. So I'm going to grab the y prime and put it on the outside. We factor the y prime out. So without the y prime, this is the first term, x e to the y, minus the second one is this one. Take the y prime out, you have the minus 3 left. So I have that minus 3. Okay, so this is trying to get y prime to be combined. Now we have only y prime, one y prime in the whole equation. There's no change to the right side of the equation. Right? And then that we're ready for step 3. In step 3, we aim to solve for the y prime. Step 3. Now that y prime is all together, we're gonna try to solve for y prime. Good. Sure. All right, so all we have to do is to factor. This is already factored. We divide it, so we have y prime is equal to what's on the right side of the equation divided by the factor of the y prime. So we divide it by x e to the y. So this is a calculation question. I think it's one of the homework question 2.7. We try to locate this one. It would be exactly that one. The question number 1 on the homework. Please, as you were trying to practice them, make sure you have this already. After you practice them, try to submit it online. All right, we're trying to find a single value when the x equals 2, y equal to 2. So the y prime, when x equal to 2, y equal to 2, the y prime is equal to 3 minus e to the power 2 over 2 e to the power 2 minus 2. So that will be the calculation. You might want to use your calculator if you want a decimal answer. But if you don't look for any simplification, I guess that's already the answer. I will be okay to stop here for the solution for 14. This will be okay. So the formula 3 minus e squared over 2e squared minus 3 is after you substitute x equal to y equal to 2, and that's already the answer that is permitted on whiteboard. So I'm okay with it. Any question? So that's solution for 14. Any question? I see if you are able to finish the 2.6 question number 1 without any assistance, just by yourself. If you can solve this question with no additional help, that probably means you can handle this question. Any other question for the test? Other test related questions? If there's no other question, let's see. I guess 13 and 14 may be the hardest one. I guess that's part of the reason it's the last question. Let's look at the rest of them and you can check the solution out one by one and see. Question number 1 is to determine equation of the tangent line. Normally, what you need to remember the equation of tangent line is y equal to f prime of the tangency multiplied by x minus c plus f of c. So that's really the formula. In the question, you have given information f1 equal to 4, f prime y equal to 7. So both of the derivative in the function is given by the x value equal to 1. So we realize x equal to 1 is a point of tangency. And that means in the tangent line equation, the c equal to 1. So once you realize c equal to 1, we're going to start rewriting the equation. C equal to 1, that's x minus 1. C equal to 1, that's f of 1, f prime of 1. Now we already have f1 that equal to 4. We also have f prime of 1 equal to 7. So that is substituted. So the last line of the equation will be the final answer. That's pretty much how the question line is. So it's a typical example of a tangent line calculation, equation of tangent line determination. Question 1. Now, question 2 is to try to find the x value where the two functions have the same tangent line. So for what value the tangent line is parallel to this line. So when the tangent lines are parallel, they will have the same slope. So what you're going to do is you find the y value for both functions. These are two separate functions. So you set the derivative equal. So the first function, you find the derivative 4x cubed plus 30x squared plus 73x plus 36. You find the derivative, it will be 12x squared plus 60x plus 73. Right, so that's one derivative. This one is y equal to x plus 0.7. And if you try to find the derivative is 1. So this y prime over on the left and this y prime on the right, we got to equal to each other, so we're going to set them equal. So that's where we set them equal. And then this now is the equation. If you want to solve for the x value, you have to solve the equation. Whenever you need to solve equation of something, you have to take a look at that equation and determine what kind of equation it is. If it's an exponential equation, you solve it with logarithm. If it's a root equation, square root equation, you have to solve it with square of both side equation. Now, this is a degree 2 polynomial. A degree 2 polynomial is what people call quadratic equation. So solving the quadratic equation, there are two methods. For one, if it's difficult to factor, we would do quadratic formula. But if it's easy to factor normally make the equation a lot easier to solve. I think we went by. All right, I started by simplifying the equation. Subtract 1 from both sides of the equation, and we see there are 12, 16, and 72. I divided all by 12. So if you look at the equation, you don't know for sure, do we have any common factor? One of the ways to go small, so you can see 12, 60, and 72. If you don't realize the all factor of 12, you can see at least they're even number, right? You can divide both sides of the equation by 2. And if they're still even number, you divide both sides of the equation by 2 again until there's nothing you can divide out. So you can factor them like slowly. You can divide both sides by 2. Then they're going to be 6x squared, 30x, and 36, right? And then there's still even number. You divide by 2 again, and then you're going to see 3. once the number gets smaller, it's easier to see the common factors. But this one, I just went ahead because I see it's 12 and then 60 and then 70. I felt like 72 minus 60 is 12 and then 60 is 5 times the 12. So I divided by 12 because that way the coefficient will be smaller. So after divide them all by 12, and then now we can factor. So you can see 6 equals 3 times 2, and 3 plus 2 is 5. So we can factor them. Once you factor them, you're going to make the x plus 3. And make every factor equal to 0. It's 0, right? X plus 3 equal to 0, then x equal to negative 3. X plus 2 equal to 0, then x equal to negative 2. And this question has two solutions, a negative 2 and negative 3. Yes.
Could you show us an example of the question 2.7?
Oh, yeah. I'm looking for. You worry about tomorrow test have one that you're not familiar with. Yes. Well, the 2.7 has two type of question. The one that is this kind of question and this kind of question. I think this is the kind that I might choose to have because they are more. It gives me more freedom of how do I change it. I can change that to a power 2 or this one to a number 4. So I can change the 5 to 4, 3 to 2. So it's made it possible for me to vary it. The other type of question is this type. You have the equation where your derivative is equal to the reciprocal of the slope. So it has a really strong design in its own. So the kind of question, if I change one, it causes a lot of other changes. It's difficult to vary on my part to design a different type of question. So this probably won't be the one that we'll be using. And another thing is inverse trig is the one that have a bigger impact in the future. So I probably would use this question, or not this kind of question. We do want to understand the reasoning that the derivative, the inverse is the 1 over the derivative, the original. So we do hope to have that idea in there, but we don't have to quiz over them. So probably gonna not take that kind of question. And another thing is many people have more problem with this kind of question. So the problem I might choose will be number 5 or number 6 for tomorrow. So that's fun. Any other questions? All right, so try this. This one, the derivative of 5 as sine inverse will be, so you have 5, that's a scalar or a number that's multiplied function. Because the 5 has 0 derivative, we don't have to apply product rule. We'll think this as one variable. So then there's one calculation of the derivative. So 5 is a coefficient multiplied by the derivative sine inverse, which is 1 over, to show 5 is multiplying by derivative sine inverse is 1 over square root of 1 minus x squared. We don't have x squared, we have x cube. So the x cube has to be squared. So that's the outside function. On the outside, it's sine inverse. Derivative of sine inverse is 1 over square root of 1 minus x squared. And then that is handling the derivative sine inverse. And then we have the derivative, the inside function, the derivative of 3x squared. Derivative of x cube is 3x squared. 3x squared. So that's how it looks like. Okay, so then this shows how it is 5 times 1 over the root of 1 minus the inside is being squared. So it's a chain rule applied to the inverse trig. Questions? So that's this one. The last one, I think I answered it before. Is differentiating the power 8. So if you want to differentiate power 8, you have to bring the 8 to the front. The whole sine inverse of 8x to the power 7 is power 7. So 8x to the front, this whole original function has to lower the power. So that's outside of power. Outside is power function. And then the next layer will be the sine inverse. Derivative of sine inverse is 1 over square root 1 minus the 8x plus 7 squared. So that's the root of the derivative of the inverse sine. And then the inside function is 8x plus 7, derivative of 8x plus 7 is 8. And that's why we have the 64. 64 is actually a power multiplication of 8 and 8. 8 from that one and 8 from this one. So I have 64. So that's the one that we practiced before together. Any other question? So either one of these two might be changing the number and use it for the test. Okay, so that's number 2. Number 3, we have the trigonometry. The solution is over here as a derivative cosecant. I think I differentiated cosecant. Derivative cosecant is negative cosecant times cotangent. Why is that true? You can prove it by using the quotient rule. So cosecant is 1 over sine, and then 1 over sine is a division. So you divide the square of the denominator, and then the root of the numerator is 0 minus the 1 times the denominator's derivative. That's why it's negative cosine over sine squared. That's negative cosecant over multiple 1 over sine. So this is proving the formula within the formula. That's the formula. Calculation of it is on the left. Derivative cosecant is negative cosecant times cotangent. Now derivative of e to the x times cotangent, you have to apply product rule. So e to the x times cotangent of x plus e to the x times cotangent derivative is cosecant squared. So that will be x. That's one of the product rule, the 2.4 homework. So if you feel like you're not quite sure of how to do it, then we can pull out that homework question and do more practice question. The number 4 is a chain rule question. Is from section 2.5. You can look it up on 2.5. Basically, it's a exponential function. Derivative exponential function is itself multiplied by a bunch of factors. Then one of the factors is derivative of the inside function. The inside function is negative 6x, negative 6 over x. We apply quotient rule or power rule, whichever you are more familiar with. The derivative of negative 6 over x is 6 over x squared. The rest is similar to what we did. Any question? So the solution is on the left. If you look for more detail, there are a couple of other formula that was written on the right. The right side in the blog is try to review some of the past question as example. That's why it's a little bit extra. Any question? So you see that it's kind of explaining the differentiation process for each of the scenario, and those being applied over here. So what do you see on the left seems to be really short, but many of them are on the right explain why this one's shorter. So kind of a combination of the two. Try to clean, make sure the presentation on the left side is clean, but then on the right side, like it's scratch paper with a lot of formula that we're applying. Okay, so this is number 5, is determining the equation of the tangent line, which we follow equation of the tangent line formula. When you try to determine the equation of the tangent line, you write down the tangent line equation and then try to rewrite everything. C equal to 0 in this case, so x minus 0, which essentially is x. And then to write equation of tangent line, you need to have the function value and the derivative value. Now, what is the function value? We have -3, so that is -3. What is a derivative value? F prime is 0, we don't know. So we're going to go ahead and start calculating. You got your function, you have your derivative, plug in 0, F prime is 0. So the main thing is to have a plan. The moment you see the question is to determine equation of tangent line, you write down equation of tangent lines. And then whatever is necessary, you're going to go ahead and start searching for it. The f of c is a function value. You look for the question and find the function value. The f prime of c is a derivative. You look for the derivative. If you don't have the derivative, you might have to calculate the derivative, and then you have to plug in 0 to find your f prime of 0, and that kind of thing. Any question? The number 6 doesn't have special things. All we have to do is remember how to differentiate exponential function and logarithm function. So those are applying the formula that we learned in 2.3. So that was a 2.3 question.
What section is, question 5?
This one, I think it's also from 2.3. Because you see the equation, we have 12x, we have e to the x. If you want to try to find the tangent line, you have to know the derivative. And 2.3 is the first time we learned those formula. Like derivative e to the x is e to the x. Derivative 12x is actually 12. So those are the kind of things that we start mentioning them in 2.3. You might find the equation of tangent line question. So the 5 and 6 are question or example you see on the homework for 2.3. 7 and 8. These are 2.4 homework. We have product rule in question 7 and we have quotient rule in question 8. Because we're applying product rule and quotient rule, I write the rule on the side. If you already remember the rule and there's not much of worry, if you don't remember the rule, you might want to write down those formula on your formula card. So then when you see a multiplication, you apply the product rule. You see the division, you apply the quotient rule. So the way I write it, they were really short. But if you want to write the product rule in more detail, maybe your calculation will be longer than this. So in this too, I did write the quotient rule of product rule down on the side, but applied it directly without writing the partial steps. So there's really very little steps in here because I was using the rule without writing it specifically. Okay, but I see a lot of students have a problem of writing the f prime of x without writing this middle step. So if you want to, when you apply the product rule, you can write a negative 2x to the fourth prime and then cosine x plus negative x to the power 4 and then cosine x prime. If you write those partial steps of the product rule and then start doing the calculation, that's a little bit more careful procedure. So I was writing here a little too fast. There's very little steps here to apply the rule. And question 9 and 10. This is also the quotient rule question. You should be able to see similar question in 2.4. Any question? And this one, the number 9, when I try to look at it, I did apply the quotient rule. So I have denominator squared, and in the numerator we have the first function prime times second function minus the first prime, and then second function prime, and then first function. So that one I did follow the quotient rule formula. That's the way I write the quotient rule. Now I start keeping the same order. So that was f prime g minus g prime f, but you can also write f prime g minus f g prime. So whichever order doesn't really matter. Multiplication, the order can always be switched. Any question? Right, that's the question 9. And then there's question 10. Quotient rule. And again, the calculation on this kind of question, because the denominator is more difficult. You can, I think I did it 2 different ways. This was calculating using the quotient rule, denominator being squared and numerator differentiated times the denominator minus the denominator differentiated times the numerator, and then derivative 6 equal to 0. So that was 0. 0 multiply anything is 0. So that's the numerator, that's the denominator, denominator, and then we have the final answer like that. So the one on the right is calculating the derivative using the quotient rule. The one on the left, I think I did, that was a calculation, right? The one on the left is plug in the x value to be a 1, like negative 12 times 1. Right, that's the x equal to 1, so 1 plus 3 is 4. So that was 4 times natural log of 4 and then square. So those are the calculation. The final decimal answer is negative 561. Negative 1.561. So pretty much I was using quotient rule the whole thing. Because in my head I was like, maybe I should use power rule. You can do 6 and then natural log x squared plus 3 to the negative 1 power. And then you can apply power. Maybe it will be faster than quotient rule. Any question? Right, so many people say that why do we have to learn quotient rule if you can write it as negative power and just pretty much use power product. But it's different perspective, and nowadays people still use quotient rule or product rule or quotient rule. So we really didn't skip the whole thing, that we still consider it as a useful formula. All right, this is the last two questions. We already talked about 13 and 14. So this is a 11 and 12. These are two questions from the section 2.5. These are chain rule questions. So the first question, you have the outside being cosine. The root cosine is negative sign. And then the root of 5x equal to 5, and you multiply them. So that's chain rule. Now for question 12, the outside is tangent. The root of tangent is secant square. And then everything else you copy. And the second layer is sine. When you differentiate the sine, the root of sine is cosine, but you want to keep the inside. And then when you're differentiating x to the power 7, you assume the outside layer has been peeled off. So when you differentiate x to the power 7, you have 7x to the power 6. It's not inside anything, right? It's like all in the open. 7x to the 8 is not inside any function anymore. The inside the function only when it's time for it. And all the other functions done integrating, differentiating, that's it. That's the chain rule. There's three functions chained together. Any questions? Right, that will be it for today. I hope that this get you more familiar about what we're gonna do tomorrow. So have a plan, make your formula early enough so you don't have to coffee or scramble to get it done before the test day. So now, and also get ready, make sure all your homework is finished. If you have any leftover homework, today the last day to get it done. Tomorrow they will be due. I think I set the due date for tomorrow, right? All right. That'll be it for today. I'll see you tomorrow. I hope everybody is doing well. And this is one of those tests that it's not a lot of like stuff. Most of them follow one formula or the other, right? So hopefully we can all do better than the first test. That'll be it for today. I'll see you tomorrow. Thank you. No, I should go get it. Sorry. I mean, I can go to one more than a week. I should go pick it up now. Here.